Okay, our next chapter, chapter 8, dealt with right triangles and trigonometry. Okay, and what we had in this chapter were a few different ways to solve for parts of right triangles, okay, side lengths, angles. And the first way we gave you was the Pythagorean theorem. If I have a right triangle with side lengths A, B, and hypotenuse C, Pythagorean theorem says that the leg squared plus the other leg squared is equal to the hypotenuse squared, or good old A squared plus B squared equals C squared. Okay, this will work anytime we know two sides of a right triangle. We can find the third side using our Pythagorean theorem. Okay, so problem 1 is a Pythagorean theorem problem, but come test time, you're not going to know that until you actually read through the question, draw things out, and start setting up the triangle. Okay, so reading through here, we have a utility pole is to be fitted with a wire. Okay, one end of the wire is to be attached at ground level, 8 feet from the base of the pole. The other end will be attached to the pole 15 feet above the ground. What's the length of the wire? Okay, let's draw that out. Let's say we have the ground and a utility pole. We're going to attach a guy wire to it, like so. We said that one end of the wire is going to be attached at the ground level, 8 feet from the base of the pole. That means ground level, 8 feet out, is going to be this distance here. The other end of the wire will be attached to the pole 15 feet above ground level. So we'll put the 15 here. Okay, what's the length of the wire? We'll call that X. And we'll assume that pole is coming out of the ground at a right angle, okay, allowing us to apply Pythagorean theorem. Again, I know two sides of a right triangle. We can solve for the third side with Pythagorean theorem. So we can set up that A squared plus B squared equals C squared, where my A and B are the legs. So we have 15 squared plus 8 squared will be equal to, in this case, we're calling it X squared. Okay, 15 squared plus 8 squared, we can just plug that right into our calculator. That gives us 289 is equal to X squared. Okay, and when I want my X, we'll just square root both sides of this equation, get the X by itself. That leaves us with X is equal to 17. Okay, so answer for us will be 17 feet. Okay, here's another classic Pythagorean theorem problem. Okay, it's going to involve some quadratic equations, some distributing, some factoring, some different things. Okay, it says find the value of X in the right triangle. Okay, so we have a couple different sides with X. And here I can use Pythagorean theorem because we do have a right triangle. I can set up that if we call this my A, this side my B, and this side my C, I can set up that A squared plus B squared equals C squared. Okay, for A squared, we're going to have the entire X plus 2 squared. Plus for B, we have an X plus 1 squared. Okay, is equal to C squared, that's going to be X plus 3 squared. Okay, then here what we have to do is actually FOIL things out, actually distribute things. Remember when we say X plus 2 squared, what we actually mean is X plus 2 times X plus 2. Okay, so that'll be plus X plus 1 times X plus 1 is equal to X plus 3 times X plus 3. So geometry problem with a bunch of algebra involved here. Let's go through this step. For my first multiplication, we'll just use the FOIL method. We'll go first. X times X will give me X squared. Okay, outer, X times 2 will give me plus 2X. Inner, 2 times X will give me another plus 2X. And last, 2 times 2 will give me a plus 4. Same thing on the second multiplication. First, X times X is X squared again. Outer, X times 1 is plus X. Inner, 1 times X will be plus X again. And last, 1 times 1 will give me plus 1. Okay, so mess on the left side. We'll simplify that in a second. Our last multiplication, x times x, will give me x squared. Outer x times 3 will give me plus 3x. Inner, we have another 3x. And last, 3 times 3 will give me a plus 9. Okay, so I'd recommend first step next to clean this up is combine your like terms. On the left side, I have 2x squared, so we'll write that as 2x squared. Okay, I have 2, 4, 5, 6 x's, so plus 6x. And a 4 plus a 1 will be plus 5. Okay, is equal to right side, we have just a single x squared. 3x plus 3x is plus 6x. And then we have a plus 9. Okay, it looks like we're left with a quadratic equation here. So a good step, first step would be get everything on the left side of the equation. Get everything set equal to 0, we should say. For that, I'm going to subtract x squared from both sides. And I'm also going to subtract 6x from both sides of the equation. Okay, the 6x's will cancel. We're left with then x squared plus 5 is equal to 9. Okay, since my x's disappeared, what I can actually do is solve this equation with a square root. I'm going to subtract 5 from both sides. That gives me that x squared is equal to 4. And then taking a square root, we end up with x is equal to just 2. Okay, so 2 is our value for x. That makes this a right triangle. Okay, a lot of nasty algebra. And then easy way to check and make sure that works is plug in 2. We'd have a 5, we'd have a 3, and we'd have a 4. Okay, 3, 4, 5 right triangle. I do know that 3 squared plus 4 squared is equal to 5 squared. Okay, so I know 2 has to be the answer for this one. Okay, so we had Pythagorean theorem, and then our Pythagorean theorem led us to our second way for solving right triangles. Those were using properties of special right triangles. Two different right triangles here, the 45, 45, 90 and 30, 60, 90. For a triangle with angles 45 degrees, and 90 degrees. Okay, if I know what one of the legs are, and the legs will be equal to each other, I can figure out the hypotenuse by just multiplying that leg by square root 2. Okay, so formula we had was hypotenuse equals square root 2 times the leg. Okay, the 30, 60, 90 was a little bit trickier. If I knew the short leg, the leg across from the 30-degree angle, I knew that the longer leg was the short leg times square root 3, and the hypotenuse is 2 times the short leg. Okay, so hypotenuse is 2 times short leg, and long leg is square root 3 times short leg. Let's take a look at using those here. Okay, so what is the value of x? Here I'm given a special right triangle. We know that we have a 90-degree angle, 60-degree angle, meaning the other angle has to be 30 degrees. Okay, I'm going to call my short leg, we'll say S, just to put a variable in that spot. Because with both those formulas I had, I couldn't go directly from my hypotenuse to the long leg, which we want to solve for, across from the 60. So I'm going to set up both my formulas here. We had hypotenuse equals 2 times, we'll say the short leg. And then my long leg was equal to square root 3 times the short leg. Okay, filling in what we know. I know my hypotenuse across from the right angle is 12. So 12 is equal to 2 times short leg S, we don't know. And then my long leg across from the 60 will be x. So we could say that x is equal to square root 3 times S, the short leg again. Okay, I can't start with my second equation because there's 2 variables, so I have to start with my first equation. I have to solve for the short leg. And with that formula, if I know my short leg, we can figure out anything else. So we'll divide both sides by 2 to get that by itself, meaning that S is equal to 6. And then once we have that 6, we can plug it in to the other formula, substitute it in, that'll give us that x is equal to square root 3 times 6 the short leg, meaning that x is just equal to 6 square root 3. Okay, so there's my long leg, there's my x. Looks like option C, 6 square root 3 for this one. Okay, that's one way to do it. The other way would be use trigonometry, which we're going to talk about in a second here. It wouldn't give you these exact answers. You'd have to actually plug things back in and check and make sure this was the actual answer. Okay, but it's a little bit cleaner, a little bit simpler if we can remember those properties of special right triangles. Okay, and then the last way we had for solving for parts of triangles was using the trigonometric ratios. Okay, if I have a right triangle and an angle A, we define the sine of A as the opposite divided by the hypotenuse. Cosine of A would be the adjacent over the hypotenuse, and tangent of A is the opposite over the adjacent. Okay, so using those, story problem to look at. It says Harrison steps out of his house to see a hot air balloon pass by. He raises his eyes at a 35-degree angle to view the balloon. If the balloon is 5,000 feet above the ground and Harrison's eye level is 5.2 feet from the ground, how far is Harrison from the balloon? So this problem actually has a nice picture for us to work with. We can turn that into a right triangle. Okay, assuming that that height is at a right angle with the ground here. Okay, we know the opposite side of that right triangle from the 35. We know an angle, and we want to solve for here. It's a little tricky, but remember when something's up in the air, we're talking about the distance directly between that object, okay, and the person on the ground, so that hypotenuse will be the x. Okay, this is a trigonometry problem because I have an angle and a side length. We can use that to solve for another side length. Here we're talking opposite and hypotenuse. That's our sine ratio. So I can set up that the sine of 35 degrees is equal to opposite 5,000 feet over hypotenuse. We'll call that our x. Okay, so we have an equation to solve for x. X is on the bottom, so first thing I'm going to do is I'm going to get rid of my fraction. I'm going to multiply both sides of that equation by x. That'll cancel out my division and leave me with x sine 35 is equal to 5,000. Okay, then last step to get x by itself, we need to undo this multiplication. So for that, I'm going to divide both sides by the sine of 35. Okay, leaving me with, okay, sine 35s will cancel on the left. X is just equal to 5,000 over sine 35. Okay, once we get the x by itself, that'll be when we plug things into the calculator. Okay, make sure you're in degree mode for this test. Otherwise, should be pretty straightforward. Plug that in, 5,000 divided by sine 35. We can say x is approximately 8,717 feet. And looks like for this question we're doing some rounding. That's closest to B, the 8,700 feet. Okay, so there's an example of using trigonometry to find a side of a triangle given an angle on another side. Okay, one more trig problem for you. And again, until you read through the question, set up the triangle, you're not going to necessarily know, what we're using, Pythagorean theorem, special right triangles, or trigonometry. Problem 5 says that Grove Street has a grade of 20%. Okay, that means that the street rises 20 feet for every 100 feet of horizontal distance. Okay, to the nearest tenth, at what angle does Grove Street rise? Okay, so we want to figure out this angle of elevation, this rising angle here. Okay, again, when we have two side lengths and we want to solve for an angle, that's trigonometry. We're talking about the opposite side we're given and the adjacent side. Okay, opposite and adjacent, that's my tangent ratio. So I can set up that tangent of x is equal to opposite 20 over adjacent 100. Okay, and when the variable we're looking for is actually this angle inside the tangent ratio, what we'll do basically is take the tangent inverse of both sides of the equation, which leaves us with x is equal to just tangent inverse of 20 over 100. Okay, so that'll be what we plug into the calculator. Second tangent, 20 divided by 100. And when I plug that in, I end up with 11.3 degrees. Okay, which looks like option A. When we have a grade of that 20%, that means that our road's rising at 11.3 degrees. Okay, so again, we can also use our trig ratios to find an angle when we're given two sides of a right triangle.